Okay, this is the video for 9.4, but before we start this, I want you to get this sheet out. So stop the video if you need to, the list of the theorems, and I want to make sure that you fill this out correctly today in class, okay? So, the first one is arc addition postulate, and the diagram would be like A, B, and C, and measure of arc AB plus measure of arc BC equal measure of arc ABC, and the measure of the arc formed by two adjacent arcs is the sum of the measure of these two arcs. Okay, the measure of the arc formed by two adjacent arcs is the sum of the measure of these two arcs. Okay, and then the other one is the definition. It's a theorem, but definition of congruent arcs. Okay, and then let's just start with writing it. So, in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So here there are two things. Okay, the central angles are congruent make the measure of arc the same, but measure of arc, like we talked about in the class, doesn't guarantee that arc length is the same, because if radius is larger then arc length is larger, and that's where this comes in, the same circle or congruent circles. If the circle is the same or congruent and the central angle is the same, then measure of the arc is the same and also lengths are the same, and therefore it's congruent. So if we draw in the diagram, let's see, here is one, and there's one on the walk, and then maybe something like this, and let's call it A, B, C, D, and let's call this I don't know, 50 degree, and the radius is 3. Here's another circle and another 50 degree, and let's call this E and F, and radius is 3. And here's another circle with 50 degree, and let's call this EFGH, and this radius is 2. Then arc AB, now don't put M because now we're talking about the arc, right? Arc is congruent to arc CD, is congruent to arc EF, but not congruent to arc GH. Okay, right. Let's move on to 9.4. So objective 9.4, this is where we are. We're going to have a review and quiz after this. Apply theorems about the chords of a circle. Okay, oh, you didn't see, sorry. And apply theorems about the chords of a circle. Okay, all right. So the arc of chord. Okay, so we learned that if you have a circle and central angle, this is called arc intercepted by this angle, and measure of arc equal measure of central angle, right? So that's what we learned about arc. Now, in the circle O shown at the right, RS cuts off arc. Okay, so another way to think about this is this arc has a central angle here. Okay, but there is also a chord that corresponds to the central angle, and this arc right here is cut off by RS. Okay, and RS refers to this one, the minor arc, and RTS, this RTS refers to the major arc, right? So one chord creates minor arc and major arc, and we speak of the minor arc as being the arc of chords RS. So when we talk about the arc of chords RS, then this is what we are talking about. Okay. Now here's the theorem 9.4. In the same circle or in a congruent circle meaning the same radius, the congruent arcs have congruent chords. So if RT is congruent RS, then arc TU is congruent arc RS, then TU and RS have the same distance. Okay, and the converse is also true. Congruent chords have congruent arcs. So if TU equal RS, then the arc TU is congruent to arc RS. Okay, and here is a paragraph proof of that. So this one is of the congruent arc have congruent chords. Start with congruent arc and go to congruent chords. Okay, but it's basically very similar proofs. So here's a diagram. Okay, so we start with arc being congruent, right? So these are congruent. That means measure of angle 1 and measure of angle 2, or the angle 1 and angle 2 are congruent, right? The congruent arcs are congruent if and only if they have same or congruent circle and they have a congruent central angle. We just filled out the congruent arc in a sheet, so these are congruent. And these are all radius, so these are congruent. So it's side angle, side, side angle, side. These triangles are congruent, and therefore TU and CRS, segment TU and segment RS are congruent by CP/CTC. The converse, let's start with these are congruent. Then we have these are all radius, so side, side, side. The triangles are congruent, and therefore measure of angle 1 and 2 are congruent, and therefore the arc TU and arc RS have to be congruent. Okay, so that's theorem 9.4. Here is a practice. If segment PQ is congruent to XY, can you conclude that arc PQ is congruent to arc RX? Why or why not? So think about this one. And if PQ is congruent to RS, can you conclude the arc PQ is congruent to RS? Why or why not? Okay, and just one more thing and we are done. Okay, midpoint of arc, bisector of arc. Okay, the point Y is called midpoint of arc XYZ if arc XY is congruent to arc YZ. Any line, segment, or ray that contain Y bisects arc XYZ. So for example, if I have a diameter that goes through Y, this diameter is bisecting this arc XYZ because it goes through Y, and arc XY is congruent to arc YZ. I have one more thing I want to show you, and that's this. Okay, so this is chord AB and chord CD, and right now I have length of 8.5, central angle of 89.6, And the length of the arc, we talked about this, length of the arc, we don't have to measure it right now, but we talked about it, that being different from measure of arc. So measure of arc would be 89.6, but the length of the arc is 9.4 here. And if I move this, here the arc moves together. Okay, and this one moves like this, so you can see. Okay, so same angle, same chord, and arc lengths are the same. Okay, so congruent arcs have congruent chords, and congruent chords have congruent arcs, and that's the same even if they overlap it. Look, okay, now I have overlapping chords, right? Chords are still congruent. It's 11.7. Central angles are the same, and arcs are still congruent. Okay, and if what happens if these chords overlap them? So like that, and they become a diameter, and these becomes, it's rounding error, so not actually coming up exactly the same, but it should give you the semicircle and the diameter. Okay, it's rounding, but it's not exactly on the same line, so they're not giving you the same, but this should give you 180 and the semicircle, the half of the circumference of the circle. Okay.